Today class we are going to discuss about context-free language and the construction of context-free grammar from the given language. So if you take the definition of CFL, a language which is generated for a context-free grammar is called a context-free language. So always language is represented with capital letter L. Grammar is represented with the G, so it denotes L of G. So this is the representation of context-free language, which contains a set of terminal and it has some derivations from the starting symbol. So I'll explain the derivation of a given grammar in later class. So first I'm going to discuss few problems for construction of context-free grammar from a language. So consider the first problem. L of G, this is a language which contains the string notations as 0 power n, 1 power n, where n greater than or equal to 1. So I already give the formation of language in first unit. So once again I repeat it. So how can you write a language means here L is equal to, if you substitute n is equal to 1, the string is 0, 1. If you substitute n is equal to 2, it is 0 squared 1 squared, that will be represented as 0 0 1 1. If n is 3, 0 cube 1 cube, so that will be written as 0 0 0 1 1. Like that the string will be going like this. So it is an infinite set of a given language. So I already give the explanation of a grammar, a context-free grammar G, which should have 4 parameters: variable, terminal, production and starting symbol. Here variable is also called as a non-terminal, which is represented within a capital letter. Terminal means it will be represented with small case letters, alphabet letters, and some symbols can also be represented with a terminal symbol. And a grammar contains collection of rules. Those rules will be defined by using productions. And the first production left side non-terminal is called as starting symbol. So how can we be able to write a context-free grammar here? So you take the first string, it is 0, 1. So I assume that the production right side symbol is 0, 1. Left side you should use only a non-terminal symbol, because if you take a context-free grammar, the rules for construction of context-free grammar is 2 rules. First rule, the length of left side of symbols should be less than the length of right side symbols. That is the first rule. And second rule, the left side symbol should be a non-terminal. Right side may be terminal followed by non-terminal, or non-terminal followed by terminal, or both combinations. So here I am taking my starting symbol non-terminal as capital A. So any alphabet letters from A to Z, you can take it as a non-terminal symbol. So A implies 0, 1. So here yes, that is the starting symbol. That starting symbol is A. And if you take terminal symbols, all the strings which is available in a language contains 0, 1. So I am using the terminal symbols 0, 1. So we can able to predict these two things. And here the left side non-terminal is capital A. So what is the starting symbol? The first production left side non-terminal is the starting symbol. Okay. So I can able to derive a string 0, 1 from this notation. So how can you derive it? You should take the starting symbol first. So instead of that symbol, you can able to substitute its right side value. So if you take A will be available at left side. So instead of A, you can able to substitute 0, 1. So now I derive a string 0, 1 from the given non-terminal capital A, which is also a starting symbol of the given grammar. Okay. Then you take the second string which contains 0, 1 at intermediate side. You note the symbols at left side and right side, the symbols are 0, 1. So, I try to write the second rule which contains the first symbol as 0 and the last symbol as 1. Intermediate symbol is 0, 1. So, it is already available as capital A. So, I substituted as 0, A1. Here I am taking the same starting symbol A here. So, how can you derive a string? The starting symbol is A. Instead of A, I can substitute the value as 0A1 because it contains a productions. So, either you can substitute 0A1, otherwise 01 because both these productions contain the same non-terminal symbol at its left side. So, 0A1. So, here this is the non-terminal symbol. Instead of capital A, I can able to substitute 01. The remaining symbols are available. So, I can able to retrieve 0011 from the given production. Then you take the third string which contains the intermediate notation as 01. So, it's not necessary to write a production as capital A implies 00A11. Instead of that, we are trying to take the second production first. So, capital A. Instead of capital A, I can able to substitute 0A1. Once again, I substitute 0A1 for the symbol and from this A, I can able to substitute 01. So, I can able to produce 00011 with the same production. Like that, all the strings which is available in a given language can able to generate with the help of these two productions. So, we can rearrange this production as those two productions contain the same left side non-terminal. So, we can write it as A implies 0A1 or 01. So, this is the production. So, what is the grammar? Grammar is VTPS. So, V is a variable that is capital A, terminals. So, this is the production. So, what are the terminal symbols available in this production? Only 0, 1. And productions are, two productions are available. One is A implies 0A1 and another one is A implies 01. What is the starting symbol? The grammar contains only one non-terminal symbol, that is also the starting symbol of the given production. So, this is the answer for the first one. Are you able to understand it? Then, I am taking the second concept. Here, the same notation is available, 0 power n, 1 power n. Instead of n value, n is starting from 0 onwards. So, what is the meaning? If you substitute n as 0, there is no string is there. So, there is no string means it is epsilon. Then the remaining symbols are 01, 0011, 000, 111 like that. So, these are all the set of strings. So, it is already derived for the productions. So, that is capital A implies 0A1 or capital A implies 01. And how can you able to produce epsilon? You can write it as A implies epsilon. That's all. So, this is the answer for the third one. Okay. Then, if you take the third problem, the context-free grammar should contain first and last symbols as same. The alphabet symbols are A, B. So, I am trying to write the correct strings. So, the first symbol and last symbols are same. So, same means the symbols may be AA. So, if it is a 2-letter word, it is AA, BB. Suppose if it is a 3-letter word, first symbol and last symbols are same. So, the middle string may be, symbol may be A or B. And if first and last symbols are same means the middle may be A or B. Are you understand it? Like that 4-letter and 5-letter strings can be able to produced from the given notations. So this is the answer. So how can you derive it? So I am taking the notations. So the set of strings are starting from 2 length. So if you take a single length, first and last symbols are same means only one symbol. So that is the first symbol, that is the last symbol. Or it may be B. Okay. So this is the notation. So I am trying to write it. So here for the single length, you should separately write the production. So the right side symbol may be A or B. So I am taking the left side non-terminal as S, for example. So any alphabet letter from capital A to Z can able to represent it as a variable which is represented at left side of production. Okay. Then if you want to produce AA, so the first letter and last letter are same. Intermediate symbol, so you check the intermediate symbol at length 3, it may be A or B. So it is already available. Okay. So I am using the same length here, same letter. So the first and last letters are same, intermediate letter may be S. So the same S will be used here. Okay. So the first two symbols can be derived, and if you are using ASA, this S can be represented as A, otherwise it can be represented as B. So your string may be AAA or ABA. So we can able to derive it. If you want to derive this one, so instead of S, you should use BSB. From the mid S, you can able to substitute either A or B. According to it, these two strings will be produced. So it's okay. So how can I able to produce two length? Either single length symbols are available, otherwise 3 length symbol. So if you want to use 2 length symbol, what is the value of S? You can substitute it as epsilon. So if you substitute epsilon at mid value, you can able to produce even length string. So these are all 5 productions. Okay, totally 5 productions are available. This is P. So what is variable? That means non-terminal, only one non-terminal. And terminal symbols are small a, small b. So terminal symbol is nothing but sigma. And then the starting symbol is S. So this is the grammar. So you try to calculate or construct a context-free grammar for first and last symbols are different. So I am giving this problem as your homework. Thank you.